Alright, so here's going to be sort of our review of 5-1, and then after that you can do the other parts or any of your homework. So in example number 1, it says the probability of flipping 4 coins and getting 4 heads is 1 out of 16. Interpret this probability. If I were to flip 4 coins many, I guess that's enough. We'll do many times, about one out of every 16 trials would have 4 heads. Alright, so that's what probability basically means. That's a 1 there. 1 out of every 16 times would have 4 heads. Okay, so let's say you flipped 4 coins 32. Are you guaranteed to get 4 heads twice? Because what they're thinking is if you take 32 and you multiply by 1 over 16, that would be 2. And the answer is no. You should get about 2, but probability doesn't guarantee one out of 16 times. And so that right there is our interpretation of probability in answer number 1. Okay. Problem number 2 says, you're playing a board game with your friends in which each turn begins rolling 2 dice. In this game, doubles the same amount of dice. Both dice is beneficial. You've rolled doubles on your last 3 turns, and one of your friends says, no way you'll roll doubles this time. That would be nearly impossible. Explain to your friend what he doesn't seem to understand about probability. Each time you roll the dice doesn't depend on previous rolls. Therefore, each time you roll the dice, you have the same probability of doubles. And for those of you who want to know the probability of rolling doubles, we said there were 36 chances, and you can go back and look in your notes, and there are 6 chances rolling doubles out of the 36, or you should roll doubles 1 out of every 6 times, which is the same for every single roll. I'm not going to do out the entire sample space because you've seen it before. Alright, quiz. School's Debate Club has 10 members, 6 females, 4 males. The team decides to pick 2 members randomly. Describe the simulation procedure. Mark on above the line, below the line, and call your method. So, in this problem, we are going to assign the females. One through 6. And we're going to assign the males to be 7 through 10, but on our number, our random number generator that we have below, we're going to make 10 equal to 0 just so that we can use one digit. So 7 through 10 really is 7, 8, 9, and 0. Alright, we're going to pick two numbers, and we want to simulate this. What is the probability of both choosing are females? And if we have two females, we count it as a success. Anything else is considered a failure. Alright, so let's take a look at our random numbers and see how we do. So we're going to use this. One thing I forgot is that we are going to have no repeats because we can't pick the same person twice. So let's go over and take a look at our number chart. Alright, so 9 was male, 6 was female, and that would be a failure because we're looking for two females. Alright, male, female, that would also be a failure. 8 and 8 would be male, can't use 8, female. So once again we have 1, which is a failure. And here we have female and female for 6 and 2, so that's a success. So we got 1 success out of 4 tries, which means our average is 0.25 or 1/4. But obviously this isn't good because we only did 4 trials. I just reread the question and said we wanted to do 10 trials, so I'm going to go to the second part of all of this. So 3 and 5 would be a success, 5 and 0 would be a failure, 4 and 2 would be a success, 8 doesn't count again, and 1 would be a failure, 2 and 3 would be a success, 9 and 7 would be a failure. So now I have 1, 2, 3, 4 successes out of 10. So I did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 trials. Alright, go ahead and work on your other worksheets or your homework or whatever you need to do, and please hand in whatever you have to hand in through your drive.